Hey, AP Physics friends, we are just about to get started on our last of the three labs. That's the Kirchoffs Law Lab. And before we do that, I want to make sure that we've got all of our understanding of circuits kind of in a nice, neat package. So I'm going to jump back for a minute to the very first lab that you did. That was that half sheet lab that we worked on last week. It had the light bulbs and the batteries, and you were making observations and making our first circuits. And we didn't really get to follow up with that one, so I wanted to do that really quickly and also label a few things. So you may want to do this in notes. You may want to just pull that lab out and write on it. Whatever works for you is just fine. So we did in class talk a little bit about how to draw the circuit for number one with a bulb and a battery, and we made the light glow. So it was going to look something like this. So you've got your bulb, you've got your battery, and just a friendly reminder that our electrons are flowing from negative to positive. They go in that direction. They make that light glow. What I really want to focus on in this video is steps 2 and 3. So the task said to now do the same thing with two bulbs and draw a diagram of your design. Now in tasks 2 and 3, you were supposed to make different circuits to achieve the same goal. And I want to make sure that you actually did do that. So that's why we're going to talk for just a few minutes here. So in the first case, and you could have done this in either order, so I don't want you to think that you did it wrong if it doesn't match, but in one of these boxes, you should have had something with a battery and then two bulbs in line with one another, okay? So it may not have looked exactly like that. It could have also looked like this. You could have put one here and then one around the corner. Okay, you could have had them both on opposite ends like this. These are all, to my eye, the exact same circuit, okay? All of these circuits allow the electrons to have one path to get from that negative terminal to the positive terminal, okay? One path to get there. You can think about this. We were talking before when we were kind of equating voltage and gravitational potential. You can kind of think about this like you climb up to the top of a water slide tower and there's only one water slide. There's only one way to get down, okay? And that's what we're talking about in this case. So in this case, we call this type of circuit a series circuit. So that's the technical term that I want you to be aware of, okay? And in a series circuit, the thing that makes it a series circuit is that all of the electrons follow the same path around the loop. And by around the loop, I mean from the negative terminal to the positive terminal. Okay, so they all follow the same path. You may have noticed and reflected in the question below that the result of this series circuit was that the bulbs became dimmer. And we're going to talk a little bit more in the next lab about why that's true. But the secret to that, I'm just, spoiler alert, is that the resistance in this case increases because there are two bulbs that each electron has to get through, two places where it has to lose some of its energy. Remember, it's got a certain amount of energy when it starts right over here, okay? It's got a certain amount of energy that's got to lose, and it's got to lose some of that here and some of it here before it moves all the way around the circuit. So that's a series. And again, you may have done that in box 2 or box 3, does not matter. But in one of those, hopefully you had a series circuit. In the other one, I hope that you had a circuit that looked something like this. In this circuit, the electrons have options. They can go around one loop or another loop. Does not matter. Now, you may not have drawn your circuit just like this, but hopefully it was something similar. So let me show you a couple of other options, things that you could have drawn. So there's your battery, and maybe you drew one light bulb like so, and then another one that went out like this. These two circuits are equivalent to me, okay? Any other way that you draw it so that all of the electrons follow one path or another, there are two separate paths, That's what we're looking for in this case, okay? In either of these situations, again, as an electron is going to fall from the negative terminal, it's going to go either through this bulb, or it's going to go, I'm going to do this kind of next to it so you can see them both, through this bulb. Okay, so it's got two different options, two different paths. You can, again, if you're thinking about like the water slide example, this is where you climb a tower to the top of the water slides and you can go down either one or the other. But once you get to the top, once that battery lifts the electron to a high potential, then it's got to fall, and it can only fall one way or another. It's not going to fall through one and then through the other. That does not make sense because we're falling from high to low. In either of these cases, we are talking about what we call a parallel circuit. Okay, and in this case, opposite of the series, all of the electrons, or I should say each electron, maybe is a better way to say this, only flows through one loop. Okay, and in our case, that means through one bulb. Okay, you may not have noticed that, well, you certainly noticed that the parallel was different from the series in terms of brightness, but in actuality, the brightness of the bulbs, two bulbs in parallel as compared to just one bulb, the bulbs are actually brighter in parallel than even just one, because the resistance goes down. There's less resistance because there are more paths, more ways to get from high to low. Hopefully this helps to define series and parallel for you. You will be ready to do your Kirchoffs Law Lab. See you soon.